Osborne Reynolds was a prominent Irish-born physicist and engineer known for his significant contributions to fluid mechanics. He was born on August 23, 1842, and passed away on February 21, 1912. Reynolds made a lasting impact on the field, particularly through his work on fluid flow and the concept now known as the Reynolds number. In the late 19th century, Reynolds conducted extensive experiments to study the behavior of fluid flow. One of his key contributions was the discovery of the transition between laminar and turbulent flow, a critical phenomenon in fluid dynamics. He observed that when the flow of a fluid, such as water or air, passes through a pipe or over a surface, it can transition from a smooth, orderly flow, laminar flow, to a chaotic, irregular flow, turbulent flow, as the flow velocity increases. Reynolds conducted experiments with water flowing through small pipes and noted that at low flow velocities, the flow was smooth and predictable, laminar. However, as the velocity increased, the flow became turbulent. He realized that the transition between these two types of flow was influenced by the ratio of inertial forces to viscous forces within the fluid. Reynolds' experiments and the introduction of the Reynolds number were groundbreaking because they provided scientists and engineers with a quantitative way to predict when flow transitions from laminar to turbulent. The Reynolds number is now a fundamental parameter used in fluid mechanics to analyze and predict the behavior of fluid flow in various practical applications, including pipe flow, aerodynamics, and heat transfer. The following example is the flow of laminar in the stream. The left situation is known as laminar flow and the right as turbulent flow. Solution is introduced from the right-hand side and pumped through the pipe. If the flow is controlled, after a small lead in length, the profile will become stable with no mixing in the lateral direction. This is termed laminar flow. If, however, the solution is pumped through the cell at a high rate, then the transport can become turbulent, where the solution movement is essentially random and unpredictable. The laminar flow occurs when the fluid is flowing slow and the turbulent flow occurs when it is flowing fast. Each of types of flow have different value of Reynolds number. For laminar flow, the Reynolds number is below 2,300. Transitional flow is between 2,300 and 4,000. Above 4,000 is turbulent flow. The following equations show how to calculate Reynolds number from the velocity, length, density, and dynamic viscosity. Reynolds number doesn't have unit and it is non-dimensional number. The following table shows comparison between laminar and turbulent flow. Besides its Reynolds number value, the laminar flow classified as low velocity flow, meanwhile turbulent is high velocity. Fluid particle in laminar flow move in straight line. In contrast, turbulent flow has irregular paths. The flow of fluid in laminar flow looks like a frozen water due to its same velocity. You can observe in this figure that the transitional flow has a combination of laminar and turbulent flow. The turbulent flow mostly observed in flow near river. That's all for today. Thank you.